Good evening everyone, good evening. I welcome you all again to your Vedantu Enlite channel. I hope you all are doing great, having a good time. So people, quickly, let me know in the chats if I'm perfectly audible and visible to every one of you first. Yes. Let me quickly know in the chats if I'm perfectly audible and visible to every one of you. Hello Creative Mind, hi Yuvashri, hello Sumantha, hello Ranjit, hello Nandini, hello Tina, hi Jimmy, hello Mosina. Hi Darshini, welcome back everyone, welcome back. Just let me know in the chats first if I'm perfectly audible and visible to every single guy, yeah? Let me quickly know in the chats, my dear people. Good evening everyone, good evening and welcome back to your Vedantu Enlite channel. Yes, Creative Mind, you can follow this series for JEE as well. I've clearly mentioned on the thumbnail, it's for NEET as well as JEE 2022 students, right? Both the students. Alright, so before starting this particular session, the ones who are new to the channel, the ones who do not know me, let me quickly introduce myself. Well, my name is Wassim Sir and I'm your chemistry master teacher writer on this Vedantu Enlite channel, right? The ones who have not liked the video yet, please do like the video, share the video with your friends, do subscribe to the channel, and do not forget to hit the bell icon so that you get the notification of every single session which we take live on this Vedantu Enlite channel, right? So do like the video, share the video with friends, and do subscribe the channel as well, okay? Yes? So quickly, let me know in the chats, my dear people, if you all are super duper excited about this particular session. Someone watching me is my neighbor, it seems. Is that? Where are you from, bro? Let me quickly know in the chats, my dear people, if all of you are super duper excited about this particular session as well. Yeah? Let me quickly know in the chats. Perfecto. All right. So basically in this session, I have come up with around some 30 questions from the thermodynamics part, not the thermochemistry part. Or maybe we'll try to do some thermochemistry questions as well, right? So there'll be around 30 questions, and by solving these 30 questions, I'm sure your whole thermodynamics chapter is going to get revised in lesser time in the form of questions, right? Perfect, guys. So let's get going then. Let's get started with the first type of question, which is on your screen now. This is the question on your screen. Look at the question carefully. You are supposed to see exactly in which reactions work is done by the gas and work is done on the gas. That's something which we need to identify, right? Let me quickly give you one basic concept by means of which we can solve these sort of questions, right? Let me first of all tell you, whenever you talk about the expansion, whenever the expansion of system happens, we always say work is done by the system. We always say work is done by the system. And whenever work is done by the system, the sign of W is taken to be negative in chemistry. That's the first thing which I would want you guys to remember. During expansion of the system, and the system over here is just going to be your ideal gas, so I can directly say, during the expansion of an ideal gas, we always say work is done by the gas or work is done by the system, and the value of W as per sign conventions is taken to be negative. Number one. Number two, during the compression of the gas, or I can generalize it, during the compression of the system, we always say work is done on the system, and whenever work is done on the system, the value of W is taken to be positive. These are the two things which I would want you guys to remember, then only we can solve this sort of equation. During compression, work is done on the system, the value of W is taken to be positive. During expansion, work is done by the system, and the value of W, the sign of W, is taken to be negative, right? Yes? Let's have a look exactly, people, how this sort of equation is to be solved. Understand. At STP, so basically it is the standard temperature pressure condition that's given to me. And this is not just a single question, my dear people, these are 4 different questions, right? Let's have a look exactly how we are going to solve these questions one by one. See, if I look at the first reaction which is given to me, the reaction is something like this. 4 times NH3 gas plus 7 times O2 gas. It gives 4 times NO2 gas, and with this you're writing 6 times water as well. So you need to see exactly during this process whether work is done by the system or work is done on the system, right? That's something which we need to check. Now, first thing, this process, this reaction is happening at STP. What that means exactly? That means the reaction is taking place at constant pressure and temperature, right? The reaction is taking place at constant pressure and temperature. I'm sure you all must have studied the ideal gas equation, that is PV is equal to nRT. Since this reaction is taking place at constant pressure and temperature, and R value that's already constant, I can clearly say volume of the gas is directly proportional to number of moles. This is the first statement which I would want you guys to remember, right? Number one. Number two, on the reactant side, how many total moles do we have? 7 plus 4. On the reactant side, we have got total 11 moles. On the product side, we have got 6 plus 4, that is 10 moles, right? So on the reactant side, we exactly have got some 11 moles. On the product side, we have got some 10 moles. So when this reaction is taking place, what is happening exactly to the number of moles? Can I say number of moles during the process is decreasing, right? During the process, number of moles are decreasing exactly. If number of moles are decreasing, that means volume of the system will decrease. And you guys know, decrease in the volume of the system is what we call as compression. And whenever there is compression, work is done on the system and the value of W is taken to be positive, right? So in the first question, you can clearly say the value of W is positive. That means work is done on the system. That's all, right? Isn't it simple and basic? Number one. Number two, you're not going to use this particular concept in the second reaction. This particular concept which I've shown you over here, that's something which you'll be using when all the reactants and products exactly are in gaseous phase. If you look at the second reaction, my dear people, your reactants are in gaseous phase and your product is in liquid state, right? Now have a look. If I talk about the second question, reactants are in gaseous phase, right? Reactants are in gaseous phase and the product is in liquid phase. That means in the second reaction, gases are getting converted into liquids. Gas is getting converted into liquid, right? What does that mean? That directly means volume of the system will be decreasing. Gas is getting converted into the liquid. That directly means volume of the system is decreasing. And decrease in the volume of the system is what we call again as the compression. And whenever there is compression, we always say work is done on the system or on the gas. So the value of W is to be taken as positive in the second case as well, right? Simple and basic. Look at the third statement, my dear people. Over here, you might get confused. See, solid getting converted into liquid, right? Solid is getting converted into liquid. A normal person thinks if solid is getting converted into liquid, that means volume should increase, expansion should happen, W value should be negative, work is done by the system. But that is not the case over here. Why is that? Have a look. See exactly, guys. So basically, if I talk about the third question, your H2O solid is getting converted into H2O liquid, right? That means ice is getting converted into liquid water. Ice is getting converted into liquid water. I'm sure you all must have studied about the structure of ice. It has got the giant structure, right, due to hydrogen bonding, due to which volume of ice will be definitely more than that of volume of liquid water, right? Due to the special structure of ice, due to hydrogen bonding, its volume will be definitely more than that of volume of liquid. So during this process, is the volume increasing or decreasing? During this process, more volume, lesser volume. Volume of the system decreases. And again, decrease in the volume of the system is what we call as compression. And whenever there is compression, we always say work is done on the gas. And whenever work is done on the gas, W value is again taken to be positive, right? So in the third case, again, we can say W value is positive. Yeah, simple and basic. Look at the last one, my dear people. Solid is getting converted into gas. Now solid is getting converted into gas. Absolutely, this is the case of expansion. Volume will definitely increase, right? Solid getting converted to gas. Absolutely, this is the case of expansion. And whenever there is expansion, we always say work is done by the system. And whenever work is done by the system, W value is taken to be negative, right? Let me quickly know in the chats if you can easily solve these sort of questions from now onwards, right? So these were 4 different questions, my dear people. This was not just a single question. These were 4 different questions in which 4 different concepts were used. I'm sure this is clear to everyone. You guys can give me some green signal in the chats so that I'll get to know whether you got this concept and I'll clearly move on to the next one. Let me know fast in the chats. Let me know fast in the chats, my dear people, if it's super clear to everyone. Yeah? I'm looking at your chats only. All right, wonderful. Let's have a look on one more question, my dear people. This is one more question. Let's see exactly how this sort of a question is to be solved, yeah? Let's see. Just a second. Well, people, if you look at this particular question, basically a graph between internal energy and temperature is given to you, right? A graph between internal energy and temperature is given to you, right? And over here, 2 points are given, point A and point B. We are supposed to check whether CV at A is more than that of CV at B, or if CV at B is more than that of CV at A, or if CV at A is equal to that of CV at B. That's something we need to check. Now, how do we tackle to this sort of a question? Look at the question carefully. The graph is made for 1 mole of an ideal gas. This particular graph, it's made for 1 mole of an ideal gas. And I'm sure you guys know, small change in the internal energy for n moles of ideal gas, that's equal to n CV dt. And this equation is only valid for ideal gas. It's not valid for the real gases, right? Because when we talk about the real gas, internal energy is the function of volume as well as temperature. Whereas in case of ideal gas, the internal energy, it only and only depends on the temperature. That's all, right? Now, people, this is the equation which gives us the small change in internal energy, right? Small change in internal energy, du, for n moles of ideal gas, right? Now, from this particular equation, I can say CV is basically equal to du divided by. It's going to be n, and over here in the denominator is going to be dt as well. Since as per the question we are given with 1 mole of ideal gas, that means the value of n is 1. If the value of n is 1, I can say CV is equal to du upon dt. What is meant by this particular equation? CV is equal to du upon dt. Can I say it's nothing, it is just giving me the slope of internal energy versus temperature curve at a particular point, right? Du upon dt is nothing, that's CV, right? And that's basically mathematically what do we mean by this particular term? It gives me the slope of internal energy and temperature curve, right? So can I say wherever the slope of U versus T curve is more, there only CV value will be more, as simple as that. Now, people, I just want to extend this line over here a bit. I just want to draw a tangent over here at point A. I'm assuming this tangent is making some angle theta A with the positive x-axis in the anti-clockwise direction, right? And I just want to make one more tangent over here at point B. This is one more tangent at point B. And I'm assuming it's making the angle theta B with the positive x-axis in the anti-clockwise direction. Now, people, I just want you guys to compare these two angles. Can I simply say theta A is greater than theta B? By just looking at these angles, I can clearly say theta A is greater than theta B. Well, if theta A is greater than theta B, can I simply say tan of theta A must be greater than that of tan of theta B, right? As simple as that. If tan of theta A is greater than that of tan of theta B, I can clearly say slope of the tangent at point A is greater than that of slope of tangent at point B. And wherever slope of tangent will be more, there only CV value is more. That's something which I told you in the beginning itself, right? More the slope of the tangent in the internal energy versus temperature curve, more is going to be the value of CV. So you got to know slope at A is greater than slope at B. So you can clearly say CV value at A is definitely greater than that of CV value at B. That's it. Right? Isn't it simple and basic, my dear people, again? So just whenever you get this type of equation in your NEET or JEE examination, this is how you are exactly going to solve this particular equation. I'm sure it's clear to everyone. Yeah? Just quickly let me know in the chats if it is super clear to everyone so that I can move on to the next one fast. Fast, my dear people. Let me quickly know in the chats if it is clear to every one of you. Perfect, guys. Let's have a look on one more question. All right. A very simple and basic question again. You can expect these sort of questions again in your NEET or JEE examination. Have a look exactly what the question says. Again, a simple and the basic one. The question says a system expands from 5 liters to 10 liters. That means the initial volume of the gas, that's given to me as 5 liters, and final volume of the gas is given to me as 10 liters, right? And the expansion of the gas is happening against a constant external pressure of how many atm? Of 2 atm. The gas is showing the expansion. Expansion of the gas is happening against a constant external pressure. As per the equation, during the expansion of the gas, the system absorbs 800 joules of heat. If the system is absorbing 800 joules of heat during the expansion, that means Q value is supposed to be plus 800 joules. Because you know, when the system absorbs heat, Q value is taken to be positive as per the sign convention. We need to calculate the value of delta U, and we need to calculate the value of delta U in joules, right? Let's give it a try. Let's see how this sort of equation is to be solved. The first thing which I would want you guys to remember, whenever in equation you see expansion of the gas is happening against a constant external pressure, you'll be considering the process to be irreversible. So first of all, this is the example of the irreversible expansion. It is the example of the irreversible expansion, number one. Number two, I need to calculate the value of delta U, and the delta U has to be in joules. I'll be simply using the first law of thermodynamics, and as per the first law of thermodynamics, delta U is nothing, it's equal to Q plus W, right? Now people, do we know the value of Q? Absolutely we know the value of Q. Do we know the value of W? No, we do not know the value of W yet. And which W it is? Is it reversible or irreversible? Right now it's irreversible. Perfect. Since if you need to calculate the value of delta U in joules, you should be having Q value with you in joules, and you should be having W value in joules as well. So I'll just modify this equation a bit. I'll say, just to make it clearly understand, I'll say Q has to be in joules and W irreversible. Absolutely, it's again supposed to be in joules, yeah? Now, as per the equation, are we given the value of Q? Absolutely, it's plus 800 joules. Do we know the value of W? We do not know it yet. Let's try to calculate the value of W first. I'll say W irreversible is nothing. Since external pressure is constant, so it's minus P external V2 minus V1. As simple as that, right people? So I can say minus times. What is the P external value that's given to me? That's 2 atm. V2 minus V1. Final volume minus initial volume. That's 5. The value comes out being minus 10. And the units right now are going to be in atm liter, because the pressure I've taken over here in atm and volume I'm taking in liters. Now people, can I directly put the value of W as minus 10 over here? No way. Why is that? Because this is in joules, this is in joules, and this has to be in joules as well, right? And do remember, 1 atm liter is 101.3 joules, right? 1 atm liter is 101.3 joules. So this value will come out to be minus 1013 joules, right? So you got the value of W. That's all. So W value is minus 1013 joules. Perfect. Now you just need to subtract it. You'll be getting the value exactly as minus 213 joules. This is the value of delta U, which exactly you were supposed to calculate that to in joules. You can just give me some thumbs ups in the chats if you got to know how to tackle this sort of equation fast. Right people, let me know quickly in the chats if it is super clear to everyone. Let me know quickly in the chats if it is super clear to everyone. Yeah? Perfect guys. I'm quickly moving on to the next question. Look at this particular question. This is again the similar sort of question which we solved a few minutes back. But the graph in this particular question is given between enthalpy and temperature. The graph right now is given between enthalpy and temperature, right? And this graph is valid for 1 mole of ideal gas. Perfect. I'm sure you all must have studied this particular relation. Small change in enthalpy dH is nothing, that's NCP dt. And this equation, it's basically valid for n moles of ideal gas. This equation is valid for ideal gas, right? I can clearly say dP is nothing, that's equal to dH divided by n, and over here it's going to be dt. Since we are given with 1 mole of ideal gas, so I must say Cp is equal to dH divided by dt, right? What is dH by dt basically? Can I say dH upon dt is nothing, it's slope of enthalpy versus temperature curve, right? dH upon dt is nothing, it's slope of enthalpy versus temperature curve. So can I say wherever the slope of enthalpy versus temperature curve is more, there only Cp value is going to be more, as simple as that. Now what I'll be exactly doing, I'll be drawing a tangent at point A. Let's assume it's making angle theta A with a positive temperature axis in the anticlockwise direction, and I'm drawing one more tangent over here, and let's assume it's making the angle theta B with this particular axis in the anticlockwise direction. Now you just need to compare these values, you just need to compare these angles. I can clearly say theta A is again greater than theta B, right? So tan of theta A must be greater than that of tan of theta B. So I must say slope of the curve at point A is supposed to be greater than that of point B. And wherever slope is more, there only Cp value is more. So I got to know Cp value at A is definitely greater than that of Cp value at B. Is that clear to everyone? Let me know quickly in the chats. A small concept involved in a small question. You can expect these sort of questions, yeah? Let me quickly know in the chats, people, if it is clear to everyone fast. Yeah? Perfect. All right, let's move on to the next one. This question, what does it say exactly? 1 mole of ideal gas undergoes a change in state from this to this with a change in internal energy of this much, the change in enthalpy delta H. All right. Let's see exactly how this sort of a question is solved. See, guys. So basically, we are given with an ideal gas, right? And when the ideal gas is present at its initial state, its pressure is given as 2 atm, its volume is 3 liters, right? Now we are changing the state of the ideal gas, and the final state parameters of the ideal gas are given as 2 atm, 7 liters, right? Yes? These are the initial state parameters of the ideal gas. These are the final state parameters of the ideal gas. What do we need to calculate? We need to calculate the value of delta H. We need to calculate the value of delta H. Well, I'm sure you are familiar with the relation delta H is equal delta U plus delta of PV. This relation is valid for both ideal as well as real gases, right? This relation I'm sure you would have come across in chapter thermodynamics. Now we will have a look exactly. Is the pressure of the gas changing? No, the pressure of the gas is not changing. Initially the pressure of the gas was 2 atm, finally also the pressure of the gas is 2 atm, right? So this process is happening, right? The process is happening and pressure of the system is remaining the same, right? If the pressure is remaining constant, you can just take P out of this delta, so it becomes P delta V. Now what we need to calculate? Delta H is equal delta U. Delta U is given to me as 30 atm liter. I'm writing the units as well so that you won't get confused at all. Plus P. What is the value of P? Since pressure is 2 atm basically, right? Delta V, change in volume. Delta V, change in volume. It's going to be final volume minus initial volume. 7 minus 3 comes out to be 4. So this value now is going to be in atm liter because I've used the pressure in atm and volume in liters, right? Now, the question is done and dusted. The final answer is going to be nothing. It's 38 atm liter, which is going to be the enthalpy change during the process, right? If, for example, you were supposed to calculate the value of delta H in joules, after this, what you were supposed to calculate? You just were supposed to multiply this term with 101.3. You'll be getting the answer exactly in joules. I'm sure this is clear to everyone, yeah? Perfecto. I'm sure you can easily solve these sort of questions from now on. Let's have a look on one more. It's a nice question, guys. I like it. See what the question says exactly. We are given with a reaction first of all. We are given with a reaction first of all. And the reaction is, I'm going to write the reaction again. It's carbon monoxide gas plus 3 times H2 gas. It gives CH4 gas plus H2O gas. This is the reaction that's given to me, right? Well, let me tell you, most of the reactions, they are carried out at constant temperature, right? You guys know it. Most of the reactions, they are carried out at constant temperature. And apart from the constant temperature term, this reaction is particularly carried out at constant pressure as well. The first thing which I'm assuming, the pressure and temperature during the process is kept constant, right? Number one. Number two, as per the question, which of the following is correct for the following exothermic reaction? It's mentioned in the question that the reaction is exothermic. If the reaction is exothermic, that means is heat absorbed or released by the system? Since the process is exothermic, heat is released by the system. And whenever heat is released by the system, you guys know, as per the sign conventions, Q value is to be taken as negative. So first thing, Q value is negative, that means less than 0. But over here, it's given as positive, right? So this cannot be the answer, number one. This cannot be the answer, number one. Number two, since this reaction is taking place at constant pressure and temperature, and few minutes back only I've told you at constant pressure and temperature, volume of the gas is directly proportional to number of moles, right? Now on the reactant side, my dear people, how many moles do we have? 3 plus 1, 4. On the product side, how many moles we have? 1 plus 1, 2. So when this reaction is happening, basically, are the moles increasing or decreasing? I must directly say moles are decreasing, right? And if the moles are decreasing, that means volume of the system will be decreasing. Volume of the system will be decreasing. And you know, decrease in the volume of the system is what we call as compression, right? And whenever there is compression, we always say work is done on the system. And whenever work is done on the system, W value is taken to be positive. So W value has to be positive. But over here, it's mentioned that W is negative. So this cannot be the answer, right? Look at the next one, my dear people. You need to get the relation between delta U and delta H, right? The first thing which I'll be calculating for this particular reaction, that's delta Ng. What is delta Ng for this reaction? I'll write number of moles of gaseous products, which is 1 plus 1, 2, minus number of moles of gaseous reactants, which is 1 plus 3, 4. The value comes out to be minus 2, right? If the value of delta Ng is minus 2, I'll directly use the relation delta H is basically equal delta U plus delta Ng RT, right? Now people, I'll write delta H as such is equal. Delta U I'm writing as such. Delta Ng is minus 2. Then it's going to be R. This is going to be T, right? Or I can say delta U is basically equal delta H plus 2 times RT, right? Look at this particular equation. Look at this particular equation, my dear people. Delta U is basically coming out to be equal to delta H plus 2 times RT. That clearly tells you delta U is greater than delta H by this much of amount, right? Delta U is greater than delta H by this much of amount, right? So delta U is greater than delta H. It's given in the option, so this is correct. That means this automatically becomes the incorrect one. So option B is going to be the actual answer of this particular equation. Let me know in the chats, my dear people, if it is super clear to everyone so that I can move on to the next one. First. Let me quickly know in the chats if it's clear to everyone. First. Yeah? Wonderful. Let's move on to one more question. Look at this particular one. The question says H2O liquid is getting converted into H2O gas. The first thing which I'll be calculating over here, that's delta Ng. What is delta Ng for this particular reaction? Number of moles of gaseous products, that's 1, minus number of moles of gaseous reactant, that is 0, because it's in liquid form. So delta Ng value is equal to 1, right? Now, delta H is equal delta U plus delta Ng RT. This is the equation which we'll be using to calculate delta U, right? You need to calculate delta U during the process. That's why I use this particular relation, right? Now guys, have a look. Have a look exactly how I'm going to solve this. First of all, I'll say delta U. Delta U I'm supposed to calculate in kilojoules, right? Yes. Delta U I'm supposed to calculate in kilojoules. Perfect. So delta U is going to be delta H minus delta Ng RT. Perfect. Now be careful with certain things. You need to calculate value of delta U in kilojoules. So delta H has to be in kilojoules and this whole term has to be in kilojoules too, right? This has to be in kilojoules and this whole term has to be in kilojoules. So I'll say delta U in kilojoules is equal to delta H in kilojoules, that's 40.66 kilojoules, right? Minus delta Ng value is 1. R value I'll be using as 8.314 joules per Kelvin per mole. And temperature of the system is given to be as 100 degrees centigrade, that means 300 Kelvin. Now people, one thing where you need to remember certain things. Since you have used the value of R as 8.314 joules per Kelvin per mole, so the units of this whole particular term is going to be right now in joules, but I do not need in joules, I need in kilojoules, so divide with 1000. Now it's going to be in kilojoules. Now you just solve this particular equation, you'll be getting the value of delta U over here exactly as 37.5 kilojoules. This is the value of delta U. Are you seeing any option as 37.5? Sorry, I've used 300, it is 373. It is 373 here, it's 100 degrees centigrade, right? Yeah. So over here you are finding one option is 337.5, but that cannot be the answer. Why is that? This is the value of delta U, my dear people. This is the value of delta U when we vaporize 1 mole of liquid water. When we vaporize 1 mole of liquid water. But as per the question, are we going to vaporize 1 mole of liquid water or 2 moles? We are going to vaporize 2 moles of liquid water, my dear people. This is the value of delta U for the vaporization of 1 mole of liquid water. So the value of delta U for the vaporization of 2 moles of liquid water is going to be something like this. The value comes out to be 75.1 kilojoules. This is the actual answer. Option B is the actual answer. Let me quickly know in the chats if you got to know how to solve this sort of equation. So read the question carefully, my dear people. It's 2 moles, right? It's not 1 mole. Yeah, I'm sure you are going to remember these things from now onwards. Yes, simple and basic. Perfect. Moving on to one more question. Look at this particular question, guys. This is again one nice question, but make sure you read the question carefully. Make sure you read the question carefully. Language is important. See. Well, as per the question, we are doing the combustion of benzoic acid, right? We are doing the combustion of benzoic acid at 300 Kelvin, temperature constant and at constant pressure. We are doing the combustion of benzoic acid at constant pressure of 1 atm, right? At constant pressure of 1 atm. Heat released is 300 kilojoules. As per the question, it's mentioned heat released during the process at constant pressure. That's QP, right? That's QP. Heat exchanged between system and surroundings at constant pressure is represented with QP. And QP is what basically for the ideal gas? It's delta H. Do you know that? QP is nothing, that's delta H. Perfect. And since heat is being released, how much heat is being released? 300 kilojoules. Since heat is being released, so the sign should be negative. So it's 300 kilojoules, right? So basically delta H is given to you. Basically delta H is given to you. What do we need to calculate? The heat released at constant volume. Heat absorbed by the system or heat released by the system at constant volume. That's represented by QV. And you guys know QV for the ideal gas is nothing. That's delta U, right? So delta U you need to calculate. Delta H is given, delta U you need to calculate. That's all. That's why I told you read the question carefully, right? Language is important. So basically you need to get the value of QV. That means delta U value you need to get. So what we need to do over here? First thing, I'll be calculating delta Ng for this particular reaction. It's going to be number of moles of gaseous products, which is 7, minus number of moles of gaseous reactants, which is 15 by 2. The value comes out being minus 1 by 2, right? Now I'll be using the relation delta H is equal delta U plus delta Ng RT, right? And I need to get the value of delta U in kilojoules, I believe, yeah, is equal. It's going to be delta H minus delta Ng RT, right? Delta H is given to us as per the question as minus 300 kilojoules. Delta Ng value we have calculated as minus 1 by 2. R value is nothing, 8.314. Temperature is given to me as 300 Kelvin. And at the same time, I'll be dividing this particular term with 1000. Then only this whole term will be in kilojoules. Now it's going to be your job to do the calculation and kill the question. That's all, right? Isn't it simple again, my dear people? This type of equation you're going to solve with the help of this particular approach, yeah? I'm sure you can solve it, right? The final answer is coming out with this much. This is the final answer. Perfecto. Alright, this is the similar sort of question. I'm not going to solve it. This is going to be your homework, or let's not keep it as the homework. It's a very simple question based on the same fact, right? Based on the same equation. Delta is equal to delta U plus delta Ng. I'm not solving this one. Okay, one more question. Look at this one. Calculate delta U and delta H. Alright, let's calculate that. Calculate delta U and delta H when 10 decimeter cube. 10 decimeter cube means 10 liters. We have got 10 liters of helium gas at STP, right? This gas is right now at STP. It's at STP right now. That means pressure of this particular gas right now, which I represent with P1, it's 1 bar. Its temperature is basically right now 0 degrees centigrade, which means 273 Kelvin, because it's mentioned that 10 liters of this gas is present at STP. That means its pressure is going to be this much, volume is going to be this much, right? Now, we are heating this particular gas. Unless the temperature of the gas reaches 100 degrees centigrade, that means 373 Kelvin. We are heating the gas up. Unless the temperature of the gas reaches 373 Kelvin, right? And you know, internal energy of the ideal gas is the function of temperature alone, right? So if you are changing the temperature of the gas, definitely its internal energy is going to change. And we need to calculate the internal energy change delta U for the ideal gas, which is nothing, that's NCV delta T, which is T2 minus T1. Isn't this the formula which you guys will be using, right? So guys, N, number of moles. I do not know the number of moles of the gas, but I know the volume of the gas, 10 liters, when the gas was at STP. So can't we calculate moles from here? Isn't it simple? Volume of the gas at STP is given, that's 10 liters. I'll clearly divide it with 22.4 liters. I'll be getting the moles, right? Given volume by 22.4. CV. Do we know the value of CV for helium? Since helium, is it the monoatomic gas? Absolutely, for the monoatomic gases, CV is nothing, that's 3 by 2 R and T2 minus T1. Final temperature minus initial temperature, that comes out to be 100, right? So if you put the value of R as 8.314, you'll be getting the final answer in joules. As simple as that, right? Again, you are supposed to calculate the value of delta H for the gas as well. And delta H is nothing, that's NCpT2 minus T1 for the ideal gas. N value, it's going to be again 10 by 22.4. Cp value for the monatomic gas is nothing, that's 5 by 2R, right? T2 minus T1 is going to be 100. Put the value of R as 8.314 and get the answer in joules. Isn't it simple and basic, my dear people? Right? I'm sure you can easily solve these sort of questions from now onwards, right? Yes? Give me some green signal from the chat so that I can solve one more different type of question. Again the simpler one. Again the simpler one. Calculate the work done in the complete decomposition of 5 moles of PCl5 in calories, alright, at 300 Kelvin. We need to calculate the value of W. So W expression, I'm sure you would have come across with this expression. W is equal to minus delta NG/RT. Right? I'm sure you would have. Yeah. So basically, I'll be calculating delta Ng first of all. What is delta Ng? Number of moles of gaseous products, 1 plus 1, 2, minus 1. 2 minus 1 is 1. Delta Ng is 1. R value I'm using in calories, 2 calories per Kelvin per mole, right? And temperature is given to me as 300. The value comes out to be exactly minus 600 calories. So is this minus 600 going to be the correct answer of this particular question? Can you let me know fast in the chats? Is this minus 600 calories going to be the correct answer of this question, guys? No way. Why is that? Because this is the value of W when we do the decomposition of 1 mole of PCl5. But as per the question, we need to do the decomposition of 5 moles of PCl5, right? Isn't it simple? This is the value of W when we do the decomposition of 1 mole of PCl5, right? But we are doing the decomposition of 5 moles of PCl5. So I'll say the work done is going to be multiplied by 5. This is going to be the work done during the decomposition of 5 moles of PCl5. This was the work done during the decomposition of 1 mole of PCl5. But we need to do the decomposition of 5 moles of PCl5. Simple again? Yeah? Let me know fast, people, if it's clear. Wonderful. Let's quickly move on to one more question of the similar type. This is one more question of the similar type. You're going to solve this question in a similar way, my dear people. What do we need to get? We need to calculate the value of W, that too in calories. The first thing which I'll be doing over here, I'll be calculating delta Ng for this particular reaction. It's going to be number of moles of gaseous products, that's 4 plus 1, 5, minus number of moles of gaseous reactants. Since this is in solid form, so 0, so it's going to be 5. Delta Ng I've calculated, right? Well, after calculating the value of delta Ng, I'll be calculating the W value, which is minus delta Ng/RT, right? So it's going to be minus times delta Ng is 5. R value in calories is 2 calories per Kelvin per mole. Temperature of the system is given to me as 27 degrees centigrade, that means 300 Kelvin. The value will come out to be minus 3000 calories. This is the value of W. But is this going to be our answer, my dear people? This is not going to be our answer. Why is that? This is the value of W when we do the decomposition of 3 moles of N2H4. When we are doing the decomposition of 3 moles of N2H4, the W value comes out to be minus 3000 calories. This minus simply tells you work is done by the system, right? So when we do the decomposition of 1 mole of N2H4, W is going to be 3000 divided by 3. But do we need to do the decomposition of 1 mole? No way. We need to do the decomposition of 5 moles. So if we do the decomposition of 5 moles of N2H4, it's going to be minus 3000 divided by 3 multiplied by 5. Just the unitary method I used. So the correct answer is going to be 5000 calories. This is basically the value of W, right? So 5000 calories of work is done by the system during the decomposition of 5 moles of N2H4. Isn't it simple, guys? Thank you, Wassim. Thank you. Let me know in the chats, my dear people, if it is clear to every single guy. Yes? Perfect. Moving on to one more. Again, one simple question. Calculate Q, W, delta U and delta H in calories when 2 moles of an ideal gas are expanded reversibly and isothermally. All right. As per the question, the ideal gas is being expanded reversibly and isothermally, right? And you guys know, whenever the ideal gas undergoes isothermal process, its delta U as well as delta H, both its values are 0, right? Whenever the ideal gas undergoes an isothermal process, its delta U as well as delta H is 0, right? So 2 questions are done, delta U, delta H done. Now, Q and W we need to calculate. Now, since the process is isothermal, So if I use the first law of thermodynamics, delta U is equal to Q plus W. Since the ideal gas is undergoing isothermal process, so delta U is 0. So I'll say Q value is equal to minus W. So just get the value of W, you'll be automatically getting the value of Q, right? Isn't it simple? Now we will have a look. I'll be getting the value of W. Since the process is reversible isothermal, so it's going to be minus nRT ln of P1 by P2. This is the equation which you'll be using to calculate work done during the reversible isothermal process. This is the equation, right? So minus times n value, number of moles of the gas, that's given to R value I'll be using in calories, right? I'll be using in calories. Perfect. Temperature of the system is given to me as 27 degrees centigrade. That means 300 Kelvin. It's going to be ln of P1 by P2. P1 is 10, P2 is 5. 10 by 5 is 2, ln 2 is 0.7. So instead of this whole, I'm writing 0.7, right? So what is the exact answer which you'll be getting over here? 2, 2, 4, 4, 3, 12. 12 multiplied by 0.7 is approximately, is it minus 940 or minus 840? Chalo, you guys solve it on your own, right? 12 multiplied by 7, how much that is? 840. So it's minus 840 calories, which is the value of W. Since you got the value of W as minus 840, so you can calculate Q as well. Q is equal to minus times W, that's minus 840. The value comes out to be plus 840 calories. So you got the value of Q, you got the value of W as well, right? Let me know fast in the chats if it's clear to everyone, my dear people. Fast. Simple and basic, just use the formula and kill the equation. That's all you need to do. Okay, look at this particular question as well. The question says 2 moles of N2 gas at 0 degrees centigrade and 5 atm are exploded isothermally against a constant axial pressure of 1 atm until the pressure of the gas reaches 1 atm. Calculate how much heat will be absorbed or released, right? See people, how am I going to solve this question? As per the question, 2 liters of N2 gas. So initial volume of the gas is 2 liters. At 0 degrees centigrade, temperature of the gas is 0 degrees centigrade. Initial pressure of the gas is 5 atm. Now the gas is being exploded isothermally. That means during this explosion, during this expansion of the ideal gas, temperature of the gas is not changing because it's mentioned, it's isothermal, right? Against a constant external pressure, the process is irreversible at the same time. Against a constant external pressure of 1 atm until the pressure of the gas reaches 1 atm. So final pressure of the gas is equal to 1 atm. Let's assume the final volume of the gas is V2, right? External pressure of the gas is given to me as 1 atm. Perfect. What do we need to calculate? We need to calculate Q. That's all. How am I going to solve this one? Any idea, guys? Do you have any idea of solving this type of question? It's a very simple one. Say, initial volume of the gas is 5 liters. Initial pressure is 5 atm. The gas is showing the expansion. Expansion is isothermal. At the same time, it's irreversible. It's irreversible. Because the expansion of the gas is happening against the constant external pressure. So it's irreversible at the same time, right? And the expansion of the gas is happening unless the pressure of the gas reaches 1 atm. We need to calculate the value of Q. For whenever the ideal gas undergoes isothermal process, you know, its delta U is 0. That means Q is equal to minus W. So in order to get the Q, we need to get the value of W, right? How do I get the value of W? See guys, it's simple. First of all, I'll be using the Boyle's law because it is the constant temperature process. P1 V1 is equal to P2 V2. P1 is 5 atm, V1 is 2 liters, P2 is 1 atm, and I'll be getting V2 from here. So V2 is nothing, that is 10 liters. So final volume I got. Since the process is irreversible, my dear people, if the process is irreversible, how do we calculate work done in the irreversible processes? Isn't it minus P external V2 minus V1? Absolutely minus P external. What is P external all about? P external is nothing, that's 1 atm. V2 minus V1. V2, 10 liters. V1, 2 liters. The value comes out to be minus 8 atm liter. Minus 8 atm liter. Or I'll just multiply it with 101.3. The answer will come in joules. This is the value of W. But do I need to calculate the value of W? No way. I need to get the value of Q. Q is going to be minus times. And W is approximately minus 808 approximately joules, right? So Q value will come out to be plus 808 joules. This is the value of Q and this is the value of W. That's all. Right? Right, people. Let me know in the chats if it is super clear to everyone again. Perfect? Okay, moving on to one more, guys. 1 mole of the monoatomic gas expands adiabatically at initial temperature capital T against a constant external pressure of 1 atm from 1 liter to 2 liters. Find the final temperature of the gas. First of all, the process is given to us as irreversible adiabatic. So as per the question, irreversible adiabatic expansion of an ideal gas is happening. Right? How come it's irreversible? Since the expansion is happening against a constant external pressure, number one. Right? It is adiabatic at the same time. Since the volume of the gas is increasing from 1 liter to 2 liters, so it's expansion, right? Now see exactly how do we solve this one. See guys, since the process is adiabatic, so Q is 0. If Q is 0, that means delta U is equal to W. Delta U is nothing, that's NCVT2 minus T1. Since it's W irreversible right now, so it's minus P external V2 minus V1, right? The question is done and dusted, I believe. Number of moles, 1. CV. For the monoatomic gas, 3 by 2R. 3 by 2R, right? T2, we need to calculate. T1, capital T, minus P external, 1 atm. V2, 2 liters. V1, 1 liter. Right? Final volume minus initial volume, that's given. What do we need to calculate? We need to calculate the value of T2. So I must say T2 is going to be capital T minus 2 divided by 3R. That is the final answer. This is the final temperature of the gas which we were supposed to calculate, my dear people. I'm sure you can solve this one from now onwards easily, right? The process was irreversible adiabatic. If it was supposed to be reversible adiabatic, this was not the procedure which you were supposed to follow at that point of time. At that point of time, the final temperature of the gas was to be calculated with the help of this formula. Right? This is the formula which you will use if the process will be reversible adiabatic. Yeah? Perfect? Alright, look at this question, guys. So basically a sample of fluorocarbon was allowed to expand. A sample of fluorocarbon was allowed to expand reversibly and adiabatically to twice of its volume. So if the initial volume is V, final volume of the gas is 2 times V, right? And the expansion is adiabatic and at the same time it's reversible adiabatic expansion. During the expansion, the temperature dropped from 400 Kelvin to 100. So initial temperature of the gas was 400 Kelvin and final temperature of the gas is nothing, that's 100 Kelvin. Assuming the ideal gas condition, calculate CV for the gas. We need to calculate CV for the gas. It's very simple question again. CV is nothing, CV is just equal to R divided by gamma minus 1. You know, this is the general result to calculate CV. So in order to get the CV, we need to get the value of gamma. Since the process is, my dear people, since the process is, just a second guys. Just a second. Okay. Since the process is reversible adiabatic, so I'll be using the equation T1 V1 raised power gamma minus 1 is equal to T2 V2 raised power gamma minus 1, right? T1 value is given to me as 400, right? V1 is, I'm writing V as such, raised power what? Gamma minus 1. T2 is equal to 100 Kelvin. V2 is 2 times V raised power gamma minus 1. So V raised power gamma minus 1, V raised power gamma minus 1 cancel. This 00 cancel. So on left hand side you have got 4. On right hand side you have got 2 raised power gamma minus 1. So 4 is nothing, that's 2 square, right? So what can we get from this particular equation? I can clearly say gamma minus 1 is equal to 2. You got the gamma minus 1. This is 2, right? So CV is nothing, that's equal to R divided by 2. This is the final answer. Yeah? Simple? Is it clear to everyone, guys? Let me know fast. If it is clear to everyone, then this is one more question which you can probably do on your own. And this is going to be the last question of the tonight's session, right? With this, dynamics part is getting over and next session is going to be our thermochemistry part, yeah? Let's see exactly, people, how do we solve this? You want me to solve this question or you guys will be doing this on your own? Can you do this on your own? Just read the question. If not, then I'll be doing it. Can you do it on your own or you want me to do it? Let me know in the chats. Let me know in the chats. Perfect then. Then this is going to be your homework question. Yeah? then this is going to be your homework question. Alright, but I would want its answers in the comment section, my dear people, right? I really want to see what is going to be your answer of this particular question. Or I'll just show you one more last question, right? A simpler one. A simpler one. What is the sign of delta S for the following reaction? You need to give the sign of delta S. First thing, do remember, if delta S is positive, that means entropy is increasing. If delta S is negative, entropy is decreasing, right? That's something which everyone knows. Now see the first part of the question. On the reactant side, this is 1, there is 2. 1 mole gives 2 moles. That means number of moles are increasing. If number of moles are increasing, that means number of particles are increasing. If number of particles are increasing, that means disorder is increasing. If disorder is increasing, that means entropy is increasing. If entropy is increasing, that means delta S is positive. So in the first question, delta S is positive, right? Second, this is 1 by 2 here. On the reactant side, we have got 1 plus 1 by 2, 3 by 2 moles. On the product side, we have got 1 mole. Number of moles are decreasing. If number of moles are decreasing, particles are decreasing. If particles are decreasing, what does that mean? That means disorder is decreasing. If disorder is decreasing, that means entropy is decreasing. If entropy is decreasing, delta S value negative, right? Then delta S should be negative. Third one, carbon dioxide solid into carbon dioxide gas. Solid getting converted into gas, that means disorder is increasing. If disorder is increasing, that means entropy is increasing, delta S positive, right? Liquid getting converted into solid, delta S negative, right? Yes, disorder is decreasing. If disorder is decreasing, entropy decreasing. Entropy decreasing matlab delta is negative. Diamond into graphite. Diamond has got ordered, this is disordered. Ordered to disordered, entropy is increasing. Delta is positive. Last one. On the reactant side, you have got gases. On the product side, you have got solid. So gases getting converted into solid. Disorder will be decreasing. That means entropy is decreasing. So delta S value is negative. That's how you solve these basic questions. Well, I'll be showing the actual questions of entropy in the next session, my dear people. With this, I'll be taking a leave. If you have not liked the video yet, please do like the video, share the video with friends, and do subscribe to the channel. And at the same time, if you have not enrolled into the JEE 2022 crash course batch yet, which is happening on the actual Vedantu platform, do get enrolled in it as soon as possible, right? If you want your whole syllabus to get completed in lesser time, and if you want the test series in that, and if you want to get trained by the best teachers of Vedantu, link is there in the description box of the video. We are starting the batch on coming Monday. Do get enrolled as soon as possible. Perfect. Take care, guys. God bless you all. Love you all. I'll see you guys tomorrow at the same time with one more quick session, the revision session. So take care. God bless you all. Love you all. Bye.